This video is for pre-calculus. I'm gonna walk you through the homework assignment that we have for section 3.2, so that you can check your answers. Hopefully you've already tried them yourself, and now you're just wanting to check to make sure that your answers are correct. If you have not, please pause this, try it using your notes, and see how you do. Okay, so for these first four, they have given us in exponential form, and we need to convert them into logarithmic form. So again, remember your base. So it's always log. The base is that subscript, and then the x is the 125, and that equals the y, which in this case is, or in every case, is the exponent. In this case, it's 3. So you should get log base 5 of 125 is 3. With the next one, it's log, my base is 8, my x is 64, and so it equals 2. This next one, log of base 2, x is 1/16, so we have a negative. And for the last one, the log of a fraction, base that equals a fraction, means you have a positive exponent. All right, so for number 2, they're in logarithmic form, and we need to convert them to exponential. So again, it's just kind of teaching you to start recognizing where all the numbers go when you convert it back and forth. So again, your base number is always that subscript. The y is the exponent, and 2 to the power of 3 equals 8. 5 to the power of 3 equals, nope, power of 2 equals 25. I always think that's 125. The base of 12 raised to the power of 2 is 144. And the base of 1/4 squared gives us 1/16. Okay. Now in these, we are solving for y. So I'm going to do kind of like we did in our notes, where I'm going to convert it to exponential form. It's usually easier to find it. No, also these are kind of the easier problems. So we're still kind of inverting back and forth between logarithmic and exponential. Okay, so I'm going to write this as 4 to the power of y is equal to 64. We want to get the same base, which we can. 4 to the power of 3 is 64, so that means that y equals 3. The next one, we have the base 6 raised to some power y. We know it's going to be negative, equals 1 over 1,296. If you use prime factorization, you'll see that 6 times itself 4 times gives you 1,296. So that means that 6 to the power of y is the same as 6 to the power of -4. You can see how the exponents can make numbers get very big very fast. So we know y equals -4. All right, this last one takes a little bit of mental gymnastics. If we go back to chapter 1 in our review of exponents, we know that we have a base of 2 raised to some power, and that it equals, I'm going to rewrite the cube root of 4 as 4 to the power of 1/3. Remember, negative means it's less than 1, greater than 0. A fraction exponent means that it's some sort of radical. So this is 4 to the power of 1/3. Now I can rewrite 4 with a base 2 raised to the power of 2 raised to the power of 1/3. And so our power property of exponents means this is 2 times 1/3. So, excuse me. So that actually equals 2 and 2/3, which means that y equals 2/3. Excuse me. All right, moving on to the next one. We are now working specifically with common log. Remember, with common log, you have an understood base of 10. So what this is saying is the log of 10 just means that we have a base of 10 raised to some exponent. Well, we know that that exponent must equal 1 because anything to 1 equals itself. So the answer is 1. In this case, I can do it the same way. This is 10 to the power of y. I'm going to write, this is a power. It's less than 1, 2, 3. Wait a minute. 1, 2, 3, 4. You can count your zeros. That's also why I put that first 0 in there, because that one counts. 10 to the power of -4. So that means that y equals -4. Now for the last two, just use your calculator. Log of 25 is going to give you approximately 1.3979. And log of E, now when you put this in your calculator, you're going to hit your log button, you're going to hit your E button, and it's going to leave you a spot there for X. Because it's only log E, just put in a 1 as your exponent. And that's going to give you approximately 0.4343. It's like 429 something something. So round up. And you get your answer. All right. For these, I did this first one in class, so if you were here for that, you can fast forward a little bit. If not, I want to talk about the domain and range. The domain and range of logarithmic functions, if there's no translation going on, no stretch, no adding to X or adding to Y, that might shift the domain a little bit. These are just the inverse of the domain and range of the exponential functions. The domain is always 0 to a positive infinity, and the range is always all real numbers, which I'm going to write in interval form. All right. Also in this case, if y equals log 4x is my f of x, I'm going to write it in exponential form as g of x. So that means that is g of x equals 4 to the power of x. Again, it goes back to the example that we did in class, where it's a lot easier to graph points of the exponential and then just invert them in order to actually graph the logarithmic function. So I'm going to go ahead and solve or calculate some points of g of x, which in this case is 4 to the power of x. So I'll use -2. That's 4 to the power of -2 is 1/16. I can't get that to erase. 1/16. 1 is 1/4. 0, of course, is 1. 1 is 4. I'm going to leave it at that since I've got a smaller graph here. But I'm going to write this. So f of x, the ordered pairs can be written as the g of x in the x spot. Just invert them, the former x in the y spot. And so we get 1/16, -2, 4, -1, 1, 0, and 4, 1. So I'm going to go ahead and graph those. So that is a little bit smaller. Okay. So -2, 1/6, super close, and then 1/4 ish here, and then 1, 2, 3, 4 up here. So we end up with something kind of like that as our f of x. Okay, obviously you can see you don't have to graph the g of x. You don't have to graph it. I just have that in the notes so you can see that they are inverses across that y equals x slanted line. All right, let's do it one more time. This one again, g of x is 5 to the power of x. So x and g of x is -2, -1, 0, and 1. That gives me 1/25, 5th, 1, and 5. Super tiny. Very, very close. 1/5, still very close. Always the same y-intercept. And way over here. So we have our somewhat smooth curve. Again, the domain and range, it's just to sort of get it stuck in your head that these are always of the parent function without sort of any translation going on, that it's always domain 0 to infinity, range, all real numbers. All right, for this next one, I don't know what I put the graphs. I got confused. You don't need the graphs. Don't worry about those. I really just want you to graph it in your calculator to take a look and make sure that it matches. Of course, I'm going to give you the answers, so you'll be able to check. Hopefully you already have and it looks good. Okay, so in this case, we're using our sort of our base, the g of x, this is the formula, is a times the log of x, that goes in parentheses, x minus h plus k. So in this case, I have no a. There's no vertical stretch or compression. but I'm translating 2 units to the left, 3 units down. So I've got a vertical translation and a horizontal translation. So I've got log of x minus, it's translating 2 units to the left though, so that means it's negative, and 3 units down mean I'm adding a negative 3. So we just simplify this, g of x equals log, parentheses, x plus 2 minus 3. And then let me, y'all can see it there. Let me switch to my calculator. Share. It should look something like this. You can see, just look at the y1, y2. Those are the only ones showing right now. We have that it has indeed shifted down 3 and to the right, or excuse me, to the left 2. So the blue is my parent, the red is my translated, my g of x. Okay, let's go back and work on the next one. All right, so for this one, we have the natural log, ln of x, translated 5 units left and reflected in the y-axis. So reflected in the y-axis means we have a horizontal reflection, so it's going to change that x. So in this case, the g of x, we have no a, no vertical stretch or shrink, and no reflection across the x-axis. So there's no negative, no a, so it's just natural log. However, the reflection across the y-axis means I have a negative x, and the fact that it's translated 5 units to the left means that I'm subtracting a negative 5, and obviously we have no vertical shift, so there's no k. So to simplify this, I'm actually going to, you could leave it this way. I don't know. That one, it kind of bugs me. I would rewrite this natural log of 5 minus x, just so you don't have all the extra signs in there, but either way will work. All right, so in this case, let me go ahead and show you what it's going to look like when you graph it. I keep hitting the wrong button. All right, let me go back to my y, and I don't want to see that. Don't want to see that. These are the ones we want to look at. Graph. So the black one is my parent function, and the pink one is my g of x, my translated function. So you can see that it has certainly inverted across the y-axis. It's heading in the other direction. And then we have our shift. In this case, it shifted to the right. That's because the shift to the left is going to happen, and then it inverts. So that's how yours should look. All right, let me go ahead and go back. All right, last one, we have f of x equals log of x reflected in the x-axis. In this case, we're using the common log, reflected in the x-axis and translated 2 units up. So the reflected in the x-axis means we have a negative in our coefficient. So you can think of it as a -1. I would just leave the negative sign. Log of x, and the fact that it's translated 2 units up means that's a k. Whoops. We now have a change to the k. So in this case, the +2 do not go inside the parentheses because we have a vertical shift as opposed to a horizontal. And so when we take a look at that, go back to the calculator, which is y. I want this one, and then there's my parent function. So parent function is blue, and you can see we have reflected across the x-axis, and we have moved up too. Okay, All right, let's go on to the rest of these. Share. Actually, that's right. We're done. These last few are, you're going to see things more like this on the test. So I may do them if we end up with some extra time. If we have another snow day, I'll go ahead and make a video covering these last two. Um, Otherwise, we'll do those when we get closer to the test. So that's it. We are done. And if y'all have any questions, like always, write them down on your form, on your sheets, so that you don't forget to ask me, and then let me know when we're back in class. Otherwise, I will see you guys next time we meet. Hopefully, we'll have a snow day. So good luck with that. Thanks.